Hashing. Hashing transforms any input data into a fixed length string of characters called a hash value. Think of it as a digital fingerprint, unique to each input. It's a one-way process. You can't reverse a hash back to the original data. Example, the word hello hashed with SHA256 becomes the output below. Real life analogy. Imagine every product in a factory gets a unique serial number. If a product serial number is scratched off or altered, you know something is wrong. Hashing is like assigning each piece of data a unique serial number to ensure its integrity. Why we use hashing? Verification ensures data integrity. If the hash of a file matches its original hash, the file hasn't been changed. Security stores sensitive data like passwords in a secure way. Only the hash is saved, not the password itself. And efficiency, verifying a hash is much faster than comparing entire files. Real life example. When downloading software, the website might display a hash value for the file, and after downloading, you can hash the file on your computer. If the hash matches, the file is intact. How hashing works. Input data of any size or type, a single word, a novel, an image. Hash function applies a mathematical process to transform the data. Output fixed size hash value, example SHA256 always outputs 256 bits. An example of this is hashing the text I love cats, and I love cats produces entirely different hashes. Small changes create dramatically different outputs called the avalanche effect. Properties of hashing. Deterministic, same input always produces the same hash. Example, hello will always hash to the same value with the same algorithm. Fixed output. Size, regardless of the input size, the hash size is consistent. An example is SHA256 always produces 256 bits, whether you hash one word or an entire novel. One-way function. You can't reverse engineer a hash to get the original input. Collision resistance. It's incredibly unlikely for two different inputs to produce the same hash. Common hashing algorithms. MD5, which is an older algorithm, fast but insecure, it can be cracked, used for checksums, example conforming downloads. SH1, improved security but now outdated, vulnerable to collision attacks. And SHA256, industry standard, highly secure and used in blockchain and cryptography. Where hashing is used. Password security. Websites don't store passwords, they store hashes of passwords. When you log in, the system hashes your input and compares it to the stored hash. File integrity checks. Downloaded files or backups can be hashed to ensure they haven't been tampered with. Digital signatures. Hashes are used to confirm a message or file's authenticity. And cryptocurrency. Bitcoin and other cryptocurrencies use hashing for mining and maintaining blockchain security. Why you can't reverse a hash. Hashing doesn't store information about the original data, it only processes it. Imagine mixing a cake batter. You can't separate the ingredients back to their original state. Even if you know the hash value, you can't derive the original data. More about hashing. Hashing is a critical part of Bitcoin mining. Bitcoin mining is the process of producing new Bitcoins by figuring out incredibly challenging mathematical puzzles that validate money transactions. Miners compete to solve a puzzle, finding a hash that meets specific criteria. This process secures transactions on the blockchain. Key takeaways. Hashing transforms data into a unique, secure fingerprint. It ensures integrity, secures sensitive information, and powers technologies like blockchain. Hashing is essential for cybersecurity, and understanding it is a step forward toward safer digital practices. Thanks for watching.